Hello students, I am your Aishwarya ma'am. Welcome to the Sankalpa learning and this is the session 1 on coordination compounds. So previous agi ನಾವು chapters ಅನ್ನ ನೋಡ್ಕೊಂಡು ಬಂದಿದ್ದೀವಿ. We have studied let me remind you that we have studied about D and F block elements. ಹೌದಾ? ಯಾಕೆ D and F block elements ಬಗ್ಗೆ ಮಾತಾಡ್ತಿದ್ದೀನಿ ಅಂತಂದ್ರೆ you will come to know within few seconds. See, ಅಲ್ಲಿ ನಾವು ಕಲ್ತಿದ್ದೀವಿ. We have studied that. We have studied some of the properties of D block elements. ಏನಪ್ಪಾ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ಅಂದಾಗ we have seen like D block elements ಅಥವಾ transition elements, they have got complex ion formation ಅನ್ನೋ ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನ ಓದಿದ್ವಿ. All the transition elements exhibit a characteristic property of complex ion formation. ಇದೊಂದು ಪಾಯಿಂಟ್ ನೋಡಿದ್ವಿ ನಾವು, and I had even told you all also that we'll be discussing this same point in the upcoming chapters anta. Here is the particular situation where we are going to study about this point in detail. ಹೌದಾ? So let me start it like this. See, for example, if you consider a dance performance, how in a dance performance, if there is good coordination between the dancers ಅಲ್ಲಿ ಒಳ್ಳೆ coordination ಇತ್ತು, if there is good coordination in the steps in the dancers, they are doing very well ಅಂತ ಅಂದ್ರೆ coordination ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ it is very nice form ಆಗುತ್ತೆ ಅಲ್ಲಿ, the dance looks very beautiful. Yes or no? Same like that, if between the atoms and the ions there is a very good coordination, yes, atoms ಮತ್ತು ions ನಡುವೆ ಒಳ್ಳೆ coordination ಇತ್ತಂತಂದ್ರೆ then we get a very 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 useful compounds which are called coordination compounds. So here my first question what comes to my mind is, what are these coordination compounds? ಹೌದಲ್ವಾ? ಏನಿದು coordination compounds ಅಂದ್ರೆ coordination ಅನ್ನೋ term is understood, fine. ಓಕೆ, ಆಟಮ್ಸ್ ಮತ್ತು ಅಯನ್ಸ್ ನಡುವೆ ಏನೋ ಕೋಆರ್ಡಿನೇಷನ್ ಅಂತಿದ್ದಾರೆ. ಕಂಪೌಂಡ್ಸ್ ವಿ ನೋ ಬೇಸಿಕಲಿ ಕಂಪೌಂಡ್ಸ್ ಅಂತಂದ್ರೆ ಏನು, ಬಟ್ ವಾಟ್ ಆರ್ ದಿಸ್, ಹೌ ಡು ವಿ ಡಿಫೈನ್ ಇಟ್, ರೈಟ್? ಸೊ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ ಅಂತ ಅಂದ್ರೆ ದೇ ಆರ್ ದ ಕಾಂಪ್ಲೆಕ್ಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. Yes, let me repeat it. What they are? They are complex molecules. They are not at all simple. They are complex molecules. Yes, so complex ಅಂದ ತಕ್ಷಣ ಏನು, their structure is very complex ಅಂತ ಅನ್ಬೋದು. They have got a very complex structure. Yes, okay, fine. So I'll write here, you can see. So coordination compounds are complex compounds. Complex ಯಾಕಂತೀವಿ? Because of their structure. They are complex compounds in which the central atom, or let me be very specific, the central metal atom is bound to a number of anions or neutral molecules by sharing of electrons. So let me recapitulate it. So coordination compounds ಅಂತಂದ್ರೆ ಏನು? Coordination compounds, they are the complex compounds. So coordination compounds ಅಂತಂದ್ರೆ they are the complex compounds in which central metal atom, ಅಂದ್ರೆ there is a metal atom, central metal atom. This central metal atom, it is bound to a number of anions athwa neutral molecules by sharing of the electrons. So let me show you an example to make it much more clear, to make the definition much more clear. Okay, so let me write here, there is cobalt, then I'm just showing you all. Here we have NH3, 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 NH3 and NH3, and here I put a box bracket, square bracket, +3 charge, and here I'll write outside the bracket Cl minus 3 ions. So what I'm not trying to actually explain you this compound. What I'm trying to say here is, just look at the structure. ಅದರದ್ದು ಸ್ಟ್ರಕ್ಚರ್ ನೋಡ್ರಿ ಎಷ್ಟು ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದೆ. ಸಿ, ನೀವು ಬಹಳಷ್ಟು ಕಂಪೌಂಡ್ಸ್ ಕಲ್ತಿದ್ರಿ. ಯು ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ H2O, you have studied NaCl, See, simple compounds these are, yes or no? So here the structure itself is complex structure. So if you look at this example, in the between, what is there in the between? If you see, there is the cobalt. CO ಅಂತಂದ್ರೆ ಏನು? Cobalt. And what is cobalt belongs to which family? Come on, tell me. Cobalt belongs to, yes, absolutely. Cobalt belongs to transition metals. Yes or no? It belongs to transition metal. So in the center will be a metal atom. That is a central metal atom, and that is transition metals. That's the reason one of the point we had studied that all the transition metal atoms exhibit the characteristic property of complex ion formation. So here cobalt is bonded to, it is bonded to 1, 2, 3, 4, 5, 6, 6. Which molecules these are? These are NH3 molecules, 6 ammonia molecules. So cobalt is bonded to 6 ammonia molecules. And what are these ammonia molecules? Ammonia molecules are neutral molecules. They are neutral molecules, yes. And these are bonded to, cobalt is bonded to NH3 molecules. How? Never ever think that it is a simple bond, ionic bond or covalent bond. Ankollik hobedri. Okay, sharing antakshna, you will come to the conclusion that it might be a covalent bond. No, absolutely not. It is not a covalent bond. Yakantandre covalent bond alli enagutte, see, you have studied about ionic bond and covalent bond. Let me not repeat it to a greater extent, but still ionic ಒಂದು definition ನೋಡ್ಕೊಂಡು ಬಿಡೋಣ. Ionic bond ಅಂತಂದ್ರೆ ಏನು? The bond formed by complete transfer of electrons between the two molecules, between the two atoms, I'm sorry. For example, if you have Na and Cl, Na, you know, atomic number is 11, chlorine is 17, configuration ಬಂದ್ಬಿಟ್ಟು 281, sodium 11. So ಇಲ್ಲಿ configuration ಬಂದ್ಬಿಟ್ಟು 287. So sodium being a metal has got the tendency to lose electrons. ಹೌದಾ? It has got the tendency to lose electrons. So what sodium does? Sodium will lose its electron. One electron ಕಳ್ಕೊಂಡು ಬಿಡುತ್ತೆ. It becomes 28. Stable ಆಯ್ತು. Chlorine, a non-metal, has the tendency to gain one electron. ಯಾಕಂತಂದ್ರೆ sodium ಒಂದು electron ಕಳ್ಕೊಂಡ ತಕ್ಷಣ it will have the configuration of 28. Octet configuration ಬಂದ್ಬಿಡ್ತು. Chlorine, the same electron will be gained. See, complete transfer ಆಗ್ತಿದೆ. ಅದನ್ನೇ ನೀವು ಲೆವಿಸ್ ಡಾಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಲ್ಲೂ ತೋರಿಸಬಹುದು. ಯು ವಿಲ್ ಶೋ ಇಟ್ ಲೈಕ್ ದಿಸ್. ಸೋಡಿಯಂ is having 1 valence electron. Chlorine is having how many? It is having 7 valence electrons. Correct? ಹೌದಾ? So what happens here? One electron from sodium is completely transferred to chlorine. So chlorine, sodium ಏನಾಗುತ್ತೆ ಅವಾಗ? Sodium becomes Na plus by losing electron. Chlorine becomes Cl minus. Electrostatic attraction between the opposite ions leading to the formation of NaCl molecule. Such type of bond is called what? Where there is complete transfer of electrons between the atoms. It is called ionic bond. Howda? And these compounds are called ionic compounds. Similarly, what are covalent compounds? Mutual sharing ಆಗುತ್ತೆ ಅಲ್ಲಿ. There is mutual sharing between the two atoms, combining atoms ಅನ್ಬೋದು. Same example you take the example of chlorine and chlorine. I'll take two chlorine atoms. Chlorine molecule ಹೇಗೆ form ಆಗುತ್ತೆ? How is this chlorine molecule formed? ಹೌದಾ? So chlorine has got how many electrons? Just now ನೋಡಿದ್ವಿ ನಾವು. There are 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. ಹೌದಾ? And this side also 1, I'm sorry, 2, 3, 4, 5, 6, 7. So ಇಲ್ಲಿ ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್ ಅಂತ ಅಂದ್ರೆ ಏನು? ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್ ಅಂತ ಅಂದ್ರೆ if this chlorine atom is going to share its one electron, this chlorine atom is also going to share its one electron. So there will be a bond of 2 electrons between 2 chlorine atoms such that octet configuration is complete for both the atoms. Such a bond is called covalent bond. ಹೌದಾ? Covalent bond ಅಲ್ಲಿ you will have single covalent bond, sharing of single electrons, ಅಥವಾ one pair of electrons between the two atoms ಅನ್ಬೋದು. You have double covalent bond, sharing of 2 pairs of electrons between the two atoms. Then you have triple covalent bond where there is sharing of 3 covalent bonds. ಹೌದಾ? But here is not that case. ಇಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗಲ್ಲ, ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗಲ್ಲ. ಸೊ ಓನ್ಲಿ ಇನ್ ದ ಡೆಫಿನೇಷನ್ ಐ ಹ್ಯಾವ್ ಸೆಡ್ ಜಸ್ಟ್ ಶೇರಿಂಗ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಹೌ ದಟ್ ಶೇರಿಂಗ್ ಆಕರ್ಸ್, this thing we'll be studying in this chapter. Fine. So illige ನೀವು ಇಷ್ಟೇ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. See, complex structure, therefore such compounds are called complex compounds, right? Now the second question which arises to my mind is, why should we study coordination compounds? why we have to study coordination compounds? ಏನಪ್ಪ ಅದರದ್ದು ನಮ್ಮ ಡೇ ಟು ಡೇ ಆಕ್ಟಿವಿಟೀಸ್ ಅಲ್ಲಿ how this can be helpful? Yes, see, coordination compounds finds a lot and lots of applications in various fields, but I will talk about simple thing. ಏನಪ್ಪ what I'm going to talk about is, you take the example of green plants. Green plants leaves are green due to a pigment called chlorophyll. Howda? What is this chlorophyll? Because ಈ pigment ಇರೋದ್ರಿಂದಾನೇ green plants can manufacture their own food by the process of photosynthesis. ಹೌದೇನಲ್ಲ? This green pigment is present, and this green pigment called chlorophyll is what? It is a coordination compound. It is a coordination compound. It is a coordination compound which contains magnesium as the central metal atom. Yes, take another example. Your hemoglobin. What is this hemoglobin? The red pigment, yes or no, of our blood. Idu hemoglobin deficiency adre enagutte heli? Person becomes anemic alla. Therefore doctor goes on writing so many drugs to increase this hemoglobin level in the body. Yakantandre blood carries, red blood cells take the oxygen what we breathe in, and it carries it to all parts of the body. Howdalla? Hemoglobin kelsa idu. It will take oxygen, hold of oxygen. ಆ oxygen ನ ತಗೊಂಡು heart ಮುಖಾಂತರ ಎಲ್ಲ parts of body ಗೆ ಹೋಗಿ ಮುಟ್ಟುತ್ತೆ. But if this hemoglobin itself is less, what will happen? Intake of oxygen becomes less. So intake of oxygen ಕಡಿಮೆ ಆಯ್ತು ಅಂತಂದ್ರೆ weakening of the body ಆಗ್ತದೆ. Under serious conditions, a person becomes highly anemic, and that causes death also. So therefore hemoglobin becomes very important in a human body, human blood ಅನ್ಬೋದು. And this hemoglobin is what? This hemoglobin is a coordination compound again. It is a coordination compound of heme. What is this heme? Heme stands for iron. Globin stands for proteins. Yes, so therefore hemoglobin. Then one more you have, that is vitamin B12. ಹೌದಾ? ಪರ್ನಿಷಿಯಸ್ ಅನೇಮಿಯಾ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತಾರೆ. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ನ್ಯೂಟ್ರಿಯೆಂಟ್ ಅಂತ ಅನ್ಬೋದು. ಸೊ ಇದು ಏನು? ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಅ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್. ದಿಸ್ ಇಸ್ ಆಲ್ಸೋ ಅ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ ಆಫ್ ಕೋಬಾಲ್ಟ್. ಸಿ ಸೋ ಮೆನಿ ನಮ್ಗೆ ಬೇಕಾಗಿರೋ ಅಂಥದ್ದೇ ಕೆಲವೊಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಕಂಪೌಂಡ್ಸ್, ದೇ ಆರ್ ವಾಟ್? ದೇ ಆರ್ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್. ಇಷ್ಟೇ ಯಾಕೆ, ಯು ಹ್ಯಾವ್ ಮೆಡಿಸಿನಲ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಮಾತಾಡಿ, ದೇರ್ ಇಸ್ ಲಾಟ್ ಆಫ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್. ಸ್ಪೀಕ್ ಅಬೌಟ್ ಟೆಕ್ಸ್ಟೈಲ್ ಡೈಯಿಂಗ್ ಇಂಡಸ್ಟ್ರೀಸ್ ಬಗ್ಗೆ ಮಾತಾಡಿ, ಲಾಟ್ಸ್ ಆಫ್ ಅಪ್ಲಿಕೇಶನ್ಸ್. ದೆನ್ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಅಂತ ಬಳಸ್ತೀವಲ್ಲ, ದೇರ್ ಆಲ್ಸೋ ವಿ ಫೈಂಡ್ ಲಾಟ್ಸ್ ಆಫ್ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ದೀಸ್ ಕೋಆರ್ಡಿನೇಷನ್ compounds. Therefore, studying these coordination compounds becomes very important. Is that clear? So you understood why we need to study coordination compounds? Fine. So now I said all transition elements, they exhibit a characteristic property. They show a characteristic property of complex ion formation. So the compounds containing this complex ions are called coordination compounds. Howda? And the branch of chemistry, the branch of chemistry which deals with, let me make it here, branch of chemistry which deals with coordination compounds is called coordination chemistry. It is called coordination chemistry. Yes, fine. So here coordination compounds na ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋಕ್ಕಿಂತ ಮುಂಚೆ, let us first try to understand compounds ಬಗ್ಗೆ ನಮಗೆ ಗೊತ್ತು. See, when solutions of two or more stable compounds na ನೀವು ಮಿಕ್ಸ್ ಮಾಡಿದ್ರೆ ಹೇಗೆ? in a simple molecular ratio, ಅಥವಾ let me be very specific, when two or more solutions of more stable compounds are mixed in a stoichiometric ratio, it forms a new crystalline compounds, and those new crystalline compounds are called molecular or addition compounds. What they are called? Molecular or addition compounds. So ಹೇಗೆ ಬರುತ್ತೆ ಇದು molecular ಅಥವಾ addition compounds? When two or more solutions of more stable compounds are mixed in a stoichiometric ratio, stoichiometric proportions, new crystalline compounds are formed, which are called molecular or addition compounds. E molecular or addition compounds alli you have two types. So what are those two types? The first type is, you call them as double salts. You call them as double salts. And the second one is our coordination compounds ಅನ್ಬೋದು, ಅಥವಾ you can call them as complex compounds also. Complex compounds anta ಕೂಡಾನು ಅನ್ಬೋದು. Fine. So let us first have a brief look at what are these double salts. Okay. So double salts ಅಂತ ಅಂದ್ರೆ ಏನು? See, the name itself says double salts. So double salts ಅಂತ ಅಂದ್ರೆ ಏನು? They are the addition compounds. They are stable in solid state, dissociate into ions in aqueous solution. See, ಏನಿವು? They are addition compounds. They are addition compounds, stable in solid state, dissociate into ions in aqueous solutions. So they dissociate into ions in aqueous solutions. So what do we mean by this? ಏನಪ್ಪ ಅದರ ಅರ್ಥ? ಏನು ಇದು ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಂತಿದ್ದಾರೆ, ಡಿಸೋಸಿಯೇಟ್ ಇಂಟು ಅಯಾನ್ಸ್ ಅಂತಿದ್ದಾರೆ. What does that mean? Fine. Let me give you an example. These all double salts are crystalline salts. Okay. So here if you see, we have KCl, MgCl2, 6H2O. So this is the addition compound which is stable. Solid state alli it exists like this only. So it will dissociate. Idanna neevu water ಒಳಗೆ solution ಮಾಡಿದ್ರಪ್ಪ ಅಂತಂದ್ರೆ, you take it and put it in, make a solution of it in water aqueous solution. It will dissociate into ions of each constituent. They will give test for each constituent. ಬೇರೆ ಬೇರೆ constituent ಗೆ test ಕೊಡುತ್ತೆ. Yes. So that is the example. This is called carnallite. What it is called? Carnallite. This is an example for double salt. You have one more very, very commonly heard. That is potash alum. Yes, ಕೇಳಿದಿರಲ್ಲ ಇದನ್ನು. What is this potash alum? K2SO4 dot Al2SO4 thrice 24H2O. Water molecules of crystallization. 24 molecules are hydrate. Crystallization ಅಂತ ಅಂತೀವಿ, ಹೌದಾ? So these are all the examples. ಏನಪ್ಪ corresponding ಏನ್ ಟೆಸ್ಟ್ ಕೊಡುತ್ತೆ? What do you said? Aqueous solutions as such give test for each constituent ion ಅಂತ ಅಂದೆ. Give test for each constituent ion. ಬೇರೆ ಬೇರೆ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಅಯಾನ್ಗೆ ಅಲ್ಲಿರುವಂತ ಎಲ್ಲಾ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಅಯಾನ್ಸಿಗೂ it will give the test. What does that mean? If you take example of carnallite, response test for which of the ions? ಅದರಲ್ಲಿ ಯಾವ್ಯಾವ ions ಇದಾವೆ ಹೇಳ್ರಿ? K plus ion is there, Mg plus 2 ion is there, then Cl minus ion is there. So you ಮೂರು ionsಗೂ it will respond for the test. Potash alum ಅಲ್ಲಿ there is K plus, there is Al plus 3, howda? Aluminium is there, and there is SO4 minus 2. For all these, it will respond test for all these ions. Getting my point? So this is a double salt. Idak navenantivi, we call it as a double salt. Now the question is, the second important thing what we are going to study, that is coordination compound anri athwa complex compounds anri. We are going to study about this in detail now. So ನಾವು ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ಸ್ ಬಗ್ಗೆ ಏನ್ ಹೇಳಿದ್ವಿಯಪ್ಪ? ವಾಟ್ ಡಿಡ್ ವಿ ಸೇ ಇನ್ ದ ಫಸ್ಟ್ ಸ್ಲೈಡ್ ಇಟ್ ಸೆಲ್ಫ್? ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ಸ್ ಅಂತ ಅಂದ್ರೆ the coordination compounds, they are complex compounds in which central metal atom is bound to a number of anions or neutral molecules by sharing the electrons. So these are also addition compounds. How the second type of addition compounds you? Yes. They are also stable in solid state, but retain their identity even in solutions. Yes, even in solution, aqueous solution alli it will retain its own identity. Andre bere ions ಗೆ ಬೇರೆ ಬೇರೆ tests ಕೊಡಲ್ಲ. Yes, let me give you an example for this complex compound. I'll explain everything in detail. So example K2PTF6. Yes. So here, this is an example for complex ion. Mattond example kodona. You have Cu, NH3, 6, SO4. Yes, this is also having a cation and anion. ನೀವು ಹೇಗೆ NaCl ಬಗ್ಗೆ ಕಲ್ತಿದ್ದೀರಿ, NaCl is having Na plus ion, Cl minus ion, cation ಐತಿ, anion ಇದೆ. Yes or no? Water H plus OH minus, there is a cation, there is a anion. Magnesium chloride Mg plus 2 ACl minus, cation and an anion. Yes or no? Similarly, these coordination compounds also have a cation and an anion, but one of the ions will be complex. That's it. ಅದಕ್ಕೆ ನಾವು ಅದಕ್ಕೆ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಾಂಪೌಂಡ್ಸ್ ಅಂತೀವಿ. And this central metal ion here, in this central metal ion, it forms a coordinate bond. Very, very, very important point. So central metal atom forms coordinate bond. Coordinate bond, which is also called dative bond, with anions or neutral molecules. Now ನೋಡಿದ್ವಿ ಅಲ್ಲ, I had taken in our previous example which I had given you. I had told you this is an example for a coordination compound anta. Haudu, this is a central metal atom. Hauda, this is central metal atom. So this is form, it is having it is attached to 6 neutral molecules, ammonia molecules attached to it. Hege, for by it is formed by which bond? This particular bond. This particular bond is called what? It is called dative bond. Adhva adak navenantivi, it is called a coordinate bond. Yes. So this is a brief introduction about complex compounds. Now here what we need to understand is, we will go step by step. Pratyondunna step by step. Certain terminologies of complex compounds na artha madkondo, then we will see the properties agirbodu, or behavior agirbodu, we'll talk about it. So when I was talking about the definition of complex compounds, I was speaking about central metal atom. Amele it is attached to NH3 molecules antella anta ide, hodalva. So what are these things? What are all these things? So what are the terminologies which are associated with coordination compounds? The first terminology what we'll be talking about is central metal atom. Central metal atom anbodu, athwa it may be an ion. So a complex ion contains a metal atom at the center. That is known as central metal atom. Yes. So a complex compound athwa a complex ion contains metal atom or ion in the center. In the center. This is called central metal atom, or it is also called as nuclear atom also. Nuclear atom. And what is this? Most of the times ಏನಿರ್ತಪ್ಪ ಇದು central metal atom? It will be a transition metal. It will be a transition metal. Central metal atom will always be a transition metal. Fine. Okay. So second thing what we are going to talk about is ಇದು complex ion ಅಂದ್ರೆ ಏನು? So what is this complex ion? So complex ion is, let me write the definition. It is electrically charged radical which is formed by the combination of simple cation with one or more neutral molecules or simple anion or in some cases positive groups also. Okay, positive groups also. So this is the definition. Complex ion andrenu, what just now I had written here. See this particular part. This is a complex ion. Yes. So complex ion anta andre it is electrically charged radical. It is having certain charge, positive ಆಗಿರ್ಬೋದು negative ಆಗಿರ್ಬೋದು, which is formed by combination of simple cation. ಅದ್ರ ಒಳಗಡೆ ಏನಿರುತ್ತೆ, it will be a simple cation. ಅದಕ್ಕೆ ನಾವು central metal ion ಅಂತೀವಿ, with one or more neutral atoms. So neutral atom irutte. In the first example I had shown, CO is there, which is attached to six NH3 molecules, yes or no? So like that, so we have complex ion at the cation with one or more neutral molecules, or there may be simple anions also, or in some cases there will be say positive I groups also. ಇದನ್ನ ನಾವು ಇನ್ನು ಡೀಟೇಲ್ ಆಗಿ ಯಾವಾಗ ತಿಳ್ಕೊತೀವಿ, when we be talking about the next particular things, that is nomenclature ಅದು ಮಾತಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ I'll tell you exactly what it is, you'll get to know. For now it is understood. Okay, coming to the third one, that is ligands. Very important part. So what are these ligands? Ligands ಅಂತಂದ್ರೆ ಏನು? They are neutral molecules or ions. Neutral molecules or ions that attach through to central metal atom or ion, and they are called ligands. Yes. So the donor atom associated with ligands, see the, for example ನಾನು ಆಗಲೇ ಹೇಳಿದೆ CO is attached to 6 NH3 molecules ಅಂತ, ಹೌದಾ? This NH3 molecules, 6 NH3 molecules are called ligands. Yes or no? They are called ligands. ಈಗ ligands ಅಲ್ಲಿ, for example, let me take this example itself. NH3 molecule is a neutral molecule, ಹೌದೇನಿಲ್ಲ? So NH3 neutral molecule ಇದೆ, it is called a ligand here because it is attached to the central metal ion. Now this NH3 molecule, which part of this will be attached? Which is having electrons. So nitrogen is having lone pair of electrons. ಹೌದು, ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂದ್ರೆ ಅದನ್ನ ಹೇಳಬೇಕಾಗಿರೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ ನಾನು. ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅಂದ್ರೆ ಏನು? ದೀಸ್ ಆರ್ ನಾಟ್ ಇನ್ವಾಲ್ವ್ಡ್ ಇನ್ ಬಾಂಡಿಂಗ್. ಸೊ ದ ಡೋನರ್ ಆಟಮ್ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಈ ಲಿಗ್ಯಾಂಡ್ ಅಲ್ಲಿ? ದ ಡೋನರ್ ಆಟಮ್ ಇಸ್ ನೈಟ್ರೋಜನ್. ಸೊ ದ ಡೋನರ್ ಆಟಮ್ ಅಸೋಸಿಯೇಟೆಡ್ ವಿತ್ ಲಿಗ್ಯಾಂಡ್ಸ್, ವಾಟ್ ಡಸ್ ಇಟ್ ಡೂ? It will supply the lone pairs of electrons to whom? It will supply the lone pair of electrons to the central metal atom. ಹೇಗೆ ಸಪ್ಲೈ ಮಾಡುತ್ತೆ? ನೀವು ಪ್ರೀವಿಯಸ್ ಸ್ಲೈಡ್ಸ್ ಅಲ್ಲಿ we have seen, see here, ಇಲ್ಲಿ ನೋಡಿದ್ವಿ ನಾವು, what we had seen here, ಟ್ರಾನ್ಸ್ಫರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗುತ್ತೆ, ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಅಯಾನಿಕ್ ಬಾಂಡ್. ಇಲ್ಲಿ ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್ ಆಗ್ತಿದೆ, ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್, ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್ ಅಂದ್ರೆ ಈಕ್ವಲ್ ನಂಬರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆರ್ ಬಿಂಗ್ ಶೇರ್ಡ್. ಇಫ್ ಕ್ಲೋರಿನ್ ಇಸ್ ಗಿವಿಂಗ್ 1 electron, this chlorine also will give 1 electron. Oxygen is giving 2 electrons, this oxygen also will give 2 electrons. ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್, ಇದಕ್ಕೆ ನಾವು ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಅಂತೀವಿ. ಬಟ್ ದ ಎಕ್ಸಾಂಪಲ್ ವಿಚ್ ಐ ವಾಸ್ ಟಾಕಿಂಗ್ ಅಬೌಟ್, ಕೋಬಾಲ್ಟ್ ಮತ್ತು NH3 ನಡುವೆ, cobalt is not going to share any of its electrons. Ammonia is going to share its electrons. Give alla. Ammonia is not going to give. Transfer ಮಾಡ್ತಾ ಇಲ್ಲ ಅದು. It is going to share its these 2 electrons, which I call them as lone pairs of electrons. To whom it is going to share? It is going to share it to the central metal ion. It is going to share with central metal ion, such that ಇವೇನು 2 electrons ಇಲ್ಲಿ ಶೇರ್ ಆಗುತ್ತಲ್ಲ, the 2 electrons shared by ammonia, they will be available for cobalt as well as for ammonia. ಸೊ ಇಲ್ಲಿ ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್ ಆಗ್ತಾ ಇಲ್ಲ. Only one atom is going to share its electrons, which are going to be taken by both the atoms. Such type of bond is called what? It is called coordinate bond. ಸೊ ಕೋಆರ್ಡಿನೇಟ್ ಬಾಂಡ್ ಎಲ್ಲಿರುತ್ತೆ? ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ ಅಲ್ಲಿ, ಹೆನ್ಸ್ ದ ನೇಮ್ ಕೋಆರ್ಡಿನೇಷನ್. ಸೊ ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್ ಅಥವಾ ಕಾಂಪ್ಲೆಕ್ಸ್ ಕಂಪೌಂಡ್ಸ್ ಅಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ ಮತ್ತು ಲಿಗ್ಯಾಂಡ್ ನಡುವೆ ಇರುವಂತಹ ಬಾಂಡ್ ಯಾವುದು? ಇಟ್ ಈಸ್ ದಿ coordinate bond. It is coordinate bond, or you can call it as dative bond. So who is giving the electrons? Who is donating the electrons? It is the ligand. Ligands are donating the electrons. To whom they are donating the electrons? They are donating, let me not make it donating, they are sharing the electrons on both. To whom they are sharing? They are sharing the electrons to cobalt. They are sharing the electrons to cobalt. Getting my point? Yes. So ಇಲ್ಲಿ for example, between the two friends, one friend ಕಂಪ್ಲೀಟ್ ಆಗಿ ತಂದೊಂದು ಪೂರ ಚಾಕ್ಲೇಟ್ ಇನ್ನೊಬ್ಬನ ಕೊಟ್ಟು ಫ್ರೆಂಡ್ಶಿಪ್ ಮಾಡ್ಕೊಂಡ, ದಟ್ ಇಸ್ ಅಯಾನಿಕ್ ಬಾಂಡ್, ಕಂಪ್ಲೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್. ಎಸ್. ಇನ್ನು ಸೆಕೆಂಡ್ ಕೇಸಲ್ಲಿ ಇಬ್ರು ಫ್ರೆಂಡ್ಸ್ ನಡುವೆ ಎರಡೆರಡು ಚಾಕ್ಲೇಟ್ಸ್ ಇದೆ, ಇವನ್ ಕಡೆ ಬೇರೆ ಎರಡು ಚಾಕ್ಲೇಟ್ಸ್ ಇದೆ, ಇವನ್ ಕಡೆ ಬೇರೆ ಎರಡು ಚಾಕ್ಲೇಟ್ಸ್ ಇದೆ. ಈ ಹುಡುಗ ಏನ್ ಮಾಡ್ತಾನೆ, ತಂದೊಂದು ಚಾಕ್ಲೇಟ್ ಯೂನಿಕ್ ಕೊಡ್ತಾನೆ, ಈ ಹುಡುಗ ತಂದೊಂದು ಚಾಕ್ಲೇಟ್ ಯೂನಿಕ್ ಕೊಡ್ತಾನೆ. ದಿಸ್ ಇಸ್ ಮ್ಯೂಚುವಲ್ ಶೇರಿಂಗ್. ಐ ಆಮ್ ಗಿವಿಂಗ್ ಒನ್, ಯು ಆಲ್ಸೋ ಗಿವ್ ಒನ್. That is mutual sharing. So that is an example for covalent bond. Yes. What is dative bond? Ibru friends idare. One is not having the chocolate, but the other one is having. He is not going to give completely. What he is going to do? He is going to give to him such that it will be eaten by both of them. That is nothing but coordinate bond. So this type of bond is between the, this type of bond exists between the central metal atom and the ligands in the coordination bond. Yes. So the donor atom, who is the donor atom here? Ligand ali, and this entire thing NH3 is called a ligand, of course. But ligand ali, there will be particular atom which is going to donate the electrons. So that is called donor atom. So ಇಲ್ಲಿ donor atom ಯಾವುದು? Which is having more electrons. So that is nothing but nitrogen. So this is nitrogen, the lone pair of electrons of nitrogen, they are going to be donated to cobalt such that both those lone pairs are being shared by both of them. So that is a dative bond or coordinate bond. So what can I say here? I can say that the donor atom associated with ligands. So here the donor atom associated with ligands, associated with ligands supplies what? Supplies the lone pair of electrons to whom? To the central metal atom, forming coordinate bond. Maybe one or two or more. Understanding? So only one lone pair can be donated. One coordinate bond agbodu. Two lone pairs can be donated. Two coordinate bonds agbodu. Three lone pairs can be donated. Depending on that, you have three types of ligands. Yes. So here we have types. Yaudappa adu types? First one is monodentate ligands. Mono, what does the term mono states? Monodentate ligands which means one donor site. Andre a particular molecule ligand alli there is only one donor atom, only one pair of electrons will be donated. For example, you have X minus, so there is, you call it as halo. Andre yaudappa, you have Cl minus, F minus, Br minus, I minus, chloro, bromo, fluoro, iodo. ಹೌದಾ ಇಲ್ಲ? Yes. Then you have OH minus. This is called hydroxo. Why I am telling the names is because nomenclaturally ಇದು use ಆಗತ್ತೆ. You should be knowing. Then you have Cn minus, which is called cyno. Then you have O minus 2, oxo. NH2 minus, amido. S minus 2, sulfido. So these are the different names. CNS minus. This is read as thiocyaneto. Cyaneto. Okay. Then we have O2 minus 2. So this is different. O minus 2. Oxo. O2 minus 2 is peroxo. Then you have CH3COO minus, acetato. Then we have NO3 minus, nitrato. Then we have CO3 minus 2, carbonato. Then SO4 minus 2, sulfato. Yes. So these are all examples for anionic ligands antanu anbodu. Anionic ligands yake? Because these are all negative ligands. Yes. We have another examples like cationic, neutral ligands. Neutral ligands alli CO barutte. What is CO? This is carbonyl. Then we have PH3. This is phosphine. Then we have The best example so far from the beginning we are talking, that is NH3, amine. Then H2O is also an example for neutral ligand, which we pronounce it as aqua. Yes. Then NO, we pronounce it as nitrosyl. Then we have C6, C5H5N, example for pyridine, which is written as PY. Okay. Then we have cationic ligands also sometimes. Like for example, NO2 plus, nitronium antivi adake. Nitronium. Then we have NH2, NH3 plus. This is called hydrazinium. Yes. Nitrosonium is there, NO plus. Nitrosonium. So these are all examples for monodentate ligands. Monodentate ligands you have. Then we have another example for bidentate ligands. ಈಗ monodentate ligands ಅಂತ ಅಂದ್ರೆ ಏನು? What are monodentate ligands? They have only one donor atom. Donor atom. ಅಥವಾ donor, we have only one donor atom. That is monodentate ligand. These are all. These are examples for anionic ligands. ಎಸ್ ಆನಯಾನಿಕ್ ಲಿಗ್ಯಾಂಡ್ಸ್. ಹೆಸರು ಯಾಕೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂತಂದ್ರೆ ನಾಮೆನ್ಕ್ಲೇಚರ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಮಗೆ ಈಸಿ ಆಗುತ್ತೆ. ದೀಸ್ ಆರ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಫಾರ್ ನ್ಯೂಟ್ರಲ್ ಲಿಗ್ಯಾಂಡ್ಸ್, ನ್ಯೂಟ್ರಲ್ monodentate ligands. Then these are examples for cationic monodentate ligands. Yes. Now coming to second part, which is called polydentate ligands. Polydentate ligands ಅಲ್ಲಿ we have types. ಏನಪ್ಪ? The first polydentate ligand is our bidentate ligand. So what are bidentate ligands? These have two donor sites. So they have two donor sites. Like for example, ಏನಪ್ಪ two donor sites ಅಂತಂದ್ರೆ, let us see. I'll take the example of, let me write here, H2N, CH2, CH2, NH2. This is an example for ethylene diamine. Which is briefly written as EN. ಎಲ್ಲೇ EN ಬರೆದ್ರು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಟ್ ಇಸ್ ಇಥೈಲಿನ್ ಡಯಾಮೈನ್. Here there are two donor sites. ಇದೊಂದು ನೈಟ್ರೋಜನ್ ಬಂದ್ಬಿಟ್ಟು ಡೋನರ್ ಸೈಟ್ ಆಗುತ್ತೆ. This also can be a donor site. Getting my point? Then you have one more example called O, C double bond O. Then we have C, C double bond O and O. Minus sign over here, minus sign over here. This one donor site, this one donor site. This is also example for bidentate ligand. It is called oxalate, which is written as OX. Then we have one more example, Me, methyl, C. Then here C, again methyl group, which is written like this. NO minus double bond NOH. This is an example for dimethyl glyoxime, oxymeto, glyoxymeto, DMG abbreviated. This is also example for bidentate ligand. Then we have one more example, NH2CH2COO minus. See, nitrogen is also a donor site. This is also a donor site. This is glycinate ion, which is written as GLY. This is also example for bidentate ligands. So what are bidentate ligands? Bidentate ligands are those which are having two donor sites and they are capable of forming two dative bonds. Understanding? So these are all the examples for bidentate ligands. Idu polydentate ligands alli barutte. Then we have example for tridentate ligand. So what do you mean by tridentate ligand? They have three donor sites. Three donor sites. So example banbittu, I'll write here, you can see NH2. So nitrogen is having one donor site, CH2 twice, then NH, another nitrogen with a donor site, CH2 twice, NH2. So you can see here, it is having three donor sites. This is called diethylene triamine. It is written as DIEN, not DIEN, okay? DIEN. This is an example for tridentate ligand. Then we have an example for tetradentate ligand. So tetradentate, tetra, the word stands for 4 donor sites. 4 donor atoms anni, donor sites anri. It is one at the same. So example banbitu, I'll write here H2N CH2 twice NH, lone pair of electrons, CH2 twice NH, lone pair of electrons, CH2 twice NH2, lone pair of electrons. This is written as triethylene tetraamine. Triene. Yes, this is an example for tetradentate ligand. Then you have one more example for hexadentate ligand. Hexadentate ligand antandrenu, it will be having 6 donor atoms athwa 6 donor sites. I'll show you the example. You can see here O minus OC CH2. Then you have N here. Then CH2 COO minus CH2 CH2 again N CH2 COO minus CH2 COO minus. Nodi ಎಷ್ಟು donor sites ಇದಾವಂತಿಲ್ಲಿ ಇಲ್ಲಿ. So here there is one donor site, the second donor site, the third one, the fourth one, the fifth one, and the sixth one. This compound is called ethylene diamine tetra acetic acid, which is abbreviated as EDTA, which is abbreviated as EDTA. So these are the examples for different types of ligands. So let us see, recapitulate it. So now kaltiruanta ligands antandrenu, they are the donor atoms. They are the donor atoms. So they will donate electrons and form they will donate electrons to the central metal atom and form a dative bond. In that ligands we have monodentate ligands, bidentate ligands, ಅಥವಾ polydentate ligands. Monodentate ligands ಅಂತ ಅಂದ್ರೇನು only one donor atom ಅಥವಾ donor site, and these are the examples. ಇಲ್ಲಿ anionic ligands ಇದೆ. Then here we have neutral ligands and cationic ligands. I hope you have taken down the names of these, which will help us to solve the next concepts, that is nomenclature ಹೇಗೆ ಮಾಡಬೇಕು ಅಂತ ಅರ್ಥ ಆಗುತ್ತೆ. Then we have polydentate ligands. Polydentate ligands ಅಲ್ಲಿ ಎಷ್ಟು ಬರುತ್ತೆ? Bidentate ligands we have, tridentate ligands we have, tetradentate ligands we have, and hexadentate. Give an example for bidentate ಅಂದಾಗ 2 donor sites ಇರುವಂತ ligands ಏನಾಗುತ್ತೆ? Bidentate ligands ಆಗುತ್ತೆ. You have EN, you have OX, you have DMG, you have GLY. So what does all these mean? EN ಅಂತ ಅಂದ್ರೆ ethylene diamine. Then OX is oxalate. It is having 2 donor sites. Dimethyl glyoximate. It is having 2 donor sites, DMG. Then glycinate ion, that is GLY, it is having 2 donor sites. So this is examples for bidentate ligands. Tridentate ligands, one example ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ ಸಾಕು. It is diethylene triamine. So it is having 3 donor sites. A tridentate ligand. Tetradentate ligand, triene. It is having 4 donor sites, that is triethylene tetramine. Yes, that is example for tetradentate ligand. And the last one is hexadentate ligand with 6 donor sites, and that is an example given for it is EDTA, ethylene diamine tetraacetic acid. ಇದನ್ನ ಹೊರತುಪಡಿಸಿ we have some what do you say, attractive other examples for ligands also. ಏನಪ್ಪ? We have something called chelating ligand. ಚಿಲ್ ಮಾಡ್ತಿದ್ದಾವೆ, ಹೌದಾ? ಸೊ ವಾಟ್ ಇಸ್ ದಿಸ್ ಚಿಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್? ಸೊ ಚಿಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್ ಅಂತ ಅಂದ್ರೆ ವೆನ್ ಅ ಪಾಲಿಡೆಂಟೇಟ್ ಲಿಗ್ಯಾಂಡ್ ಬೈಂಡ್ ಟು ಸೆಂಟ್ರಲ್ ಆಟಮ್, they form a ring structure. See, polydentate ligand ಇದೆ, it is having 2, 3, 4, 6 donor sites. When it is going to bind the central atom using 2 donor sites anni ಅಥವಾ 3 donor sites anni, it will form a ring structure, and that ring structure is called what? It is called a chelate. and the ligand is said to be chelating ligand. So let me write the definition here for chelating ligand. When this comes only when you have a polydentate ligand. When a polydentate ligand binds to central atom, central metal atom ಅಥವಾ ion ಅನ್ನಿ, they form a ring called chelate, and the ligand is called chelating ligand. Chelating ligand, right? So this is chelating ligand. We have one more type of ligand. Yenappa, what is the another one what we are speaking about? We have something called ambidentate ligand. So what is this ambidentate ligand ivaga? We have studied monodentate, one donor site, bidentate, two donor sites. So you say hexadentate, six donor sites. What is this ambidentate ligand now? Ambidentate ligand ಅಂತಂದ್ರೆ it possesses two donor atoms. ಅದು single ligand ಅಲ್ಲಿ it will have two donor atoms, but in forming complexes it utilizes only one atom. So what is ambidentate ligand? A ligand which possesses two donor atoms. Please don't get confused. Teacher, do donor atoms andre it should be a bidentate ligand. No. Bidentate ligand alli enagutte both the donor sites get attached to the central metal atom. But ambidentate ligands ಅಂತಂದ್ರೆ ಕೆಲವೊಂದು compounds ಅಲ್ಲಿ ಅದರ ಹತ್ರ two donor atoms ಇದಾವೆ. But ಕೆಲವೊಂದು compounds ಅಲ್ಲಿ it will use one of its donor atom. ಇನ್ನು ಕೆಲವೊಂದು compounds ಅಲ್ಲಿ it will use another donor atom. Getting my point? So it possesses two donor atoms, but in forming complexes, it utilizes only one atom. It utilizes only one atom depending upon the condition, and depending upon the complex. ಯಾವ ತರದ ಕಾಂಪ್ಲೆಕ್ಸ್ ಇದೆ and ಏನು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಬೇಕಾಗಿದೆ ಅದರ ಮೇಲೆ it will use its donor side. For example, NO2, which you call it as nitro, it is an example for ambidentate ligand. ಬೇಕಾದಾಗ it will use nitrogen, or sometimes it will use oxygen. ಕೆಲವೊಂದು ಕಂಪೌಂಡ್ಸ್ ಅಲ್ಲಿ ನೈಟ್ರೋಜನ್ ಯೂಸ್ ಮಾಡುತ್ತೆ, ಇನ್ನು ಕೆಲವೊಂದು ಕಂಪೌಂಡ್ಸ್ ಎರಡೂ ಒಂದೇ ಕಂಪೌಂಡ್ ಅಲ್ಲಿ ಯೂಸ್ ಆಗಲ್ಲ. ಎರಡೂ ಡೋನರ್ ಸೈಡ್ಸ್ ಒಂದೇ ಕಂಪೌಂಡ್ ಅಲ್ಲಿ ಯೂಸ್ ಆಗ್ಬೇಕಪ್ಪ ಅಂತಂದ್ರೆ ಇಟ್ ಈಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಬೈಡೆಂಟೇಟ್. ದಿಸ್ ಇಸ್ ನಾಟ್ ಬೈಡೆಂಟೇಟ್, ಆಂಬಿಡೆಂಟೇಟ್ ಇದು. ಕೆಲವೊಂದು ಕಂಪೌಂಡ್ಸ್ ಅಲ್ಲಿ ನೈಟ್ರೋಜನ್ ಯೂಸ್ ಆಗುತ್ತೆ, ಇನ್ನು ಕೆಲವೊಂದು ಕಂಪೌಂಡ್ಸ್ ಅಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಯೂಸ್ ಆಗುತ್ತೆ. ಐ ವಿಲ್ ರೈಟ್ ಅನದರ್ ಎಕ್ಸಾಂಪಲ್, ONO. See here, NO2 ನೇ ಇದೆ, ಬಟ್ ONO, that means the O is being used, ಅದಕ್ಕೆ ನಾವು ಏನಂತೀವಿ, ನೈಟ್ರಿಟೋ. It's called nitrito. Then we have CN, which is called cyno, or NC, which is called isocyno. Yes. Then we have SCN. If S is being used, it is called thiocyanide ಅನ್ಬೋದು. If N is being used, it is called isothiocyanide. Getting my point? So it is possesses two donor atoms, but in forming complexes, depending upon the condition and depending upon the complex, it will utilize only one atom. One donor atom ಅಷ್ಟೇ utilize ಮಾಡುತ್ತೆ. Then such ligands are called ambidentate ligands. Then we have something called pi acid ligands. So pi acid ligand ಅಂತಂದ್ರೆ ಏನು? So pi acid ligands means they are capable of accepting an appreciable amount of pi electrons. So pi acid ligands andre they are capable of accepting appreciable amount of pi electrons from central metal atom, into empty pi or pi star bonding molecular orbital or anti-bonding molecular orbital on their own. These are called pi acid ligands. Okay, so this is all about ligands. So now we spoke about the different types of ligands. Now the next entity, what a coordination, central metal atom andre ಏನ್ ನೋಡಿದ್ವಿ, complex ion andre ಏನ್ ನೋಡಿದ್ವಿ, ligands ಅಂತ ಅಂದ್ರೆ ಏನ್ ನೋಡಿದ್ವಿ, ಹೌದಾ? The fourth thing what we are going to talk about is, it is about coordination sphere. The next terminology, that is coordination sphere. Now what is this coordination sphere? So ligand with central metal ion, heng bariತೀವಿ ನಾವು, it is always kept in a square bracket. It will retain its identity in the same form, and that is called coordination sphere. So coordination sphere andre ಏನು? It is ligand with central metal atom or ion is kept in, how do you write it? It is kept in square bracket, box bracket ಅಲ್ಲಿ ಇರುತ್ತೆ, and retains its identity. That is called coordination sphere. Let me write an example to make all the things clear. Okay, so let us take an example here. Okay, here I write CO NH3 6, close the bracket, plus 3. So you can see here. So what are this? So let us see here now. So CO annodenu? CO, it is a metal atom, transition metal, hauda? So this is called central metal atom. Okay, central metal atom idu. Then what are these NH3? How many are there? 6 NH3 idavalla. So what are these? These are neutral molecules. They are going to donate the lone pair of electrons for sharing with central metal atom. These are called what? These are called ligands. Yes, ligands. And this entire thing is called what? This entire thing is called coordination sphere. It is called coordination sphere. Yes, we have one more terminology here, the another fifth terminology, that is coordination number. Very important thing. Coordination number, will be frequently using this coordination number, which is abbreviated as CN. So what is this coordination number? Coordination number anta andre, it is defined as the number of monodentate ligands. The number of monodentate ligands attached to the central metal atom or ion is called coordination number of central metal atom or ion. So coordination number anta andrenu, it is the number of monodentate ligands. Mark this point. Yenadu, it is the number of monodentate ligands attached to the central metal atom or ion is called the coordination number. So in the previous example, what is the coordination number? Come on, tell me. Number of monodentate. This is example for monodentate ligand. Correct. NH3 neutral molecule. Neutral ligands alli barate monodentate ligand. So how many monodentate ligands are attached to the central metal atom? There are 6 monodentate ligands. So this is nothing but coordination number. Coordination number. Is that clear? So coordination number, which you abbreviate it as CN. So idella, these are the terminologies which are associated with complex compounds. So first terminology banbitu. So here we are recapitulating the things. So coordination compounds antandre complex compounds in which central metal atom is bound to number of anions. So you can see here NH3, 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 NH3. ಎಷ್ಟು NH3 ಇದೆ? 6 NH3 ಇದೆ. Yes or no? 6 NH3 molecules are bonded to cobalt central metal atom, and they are bonded how? They are bonded by sharing the electrons. What type of bond? Coordinate bond ಅಥವಾ dative bond. So ಇದ್ರದ್ದು coordination number ಬಂದ್ಬಿಟ್ಟು ಎಷ್ಟು? The coordination number is 6. Correct? So it is, they are called coordination compounds. Examples we had seen, some of the examples for which are by our body ಮತ್ತು nearby ಅಂದಾಗ hemoglobin, chlorophyll, vitamin B12 ಬರುತ್ತೆ. So here chlorophyll, it is a coordination compound of which element? Magnesium. Hemoglobin is a coordination compound of iron. Remember it like this, heme stands for iron. Then vitamin B12 is a coordination compound of cobalt. And the branch which deals with this coordination compounds is called coordination chemistry. ಇಲ್ಲಿ coordination compounds ಕಲಿಬೇಕಂತಂದ್ರೆ ಸ್ವಲ್ಪ ಹಿಂದ್ಗಡೆ ಬ್ರೀಫ್ ಅಲ್ಲಿ ಹೋಗ್ಬೇಕಾಗತ್ತೆ. You have something called molecular or addition compounds. ಏನವು? when two or more solutions of stable compounds ಅನ್ನ ತಗೊಂಡು ಮಿಕ್ಸ್ ಮಾಡಿ ಪ್ರಾಪರ್ ಸ್ಟೈಕ್ಯೋಮೆಟ್ರಿಕ್ ರೇಷಿಯೋ, molecular ratio ಅಲ್ಲಿ ಮಿಕ್ಸ್ ಮಾಡಿದಾಗ you will get a new crystalline compound. We call it as double salt. You call them as addition compounds ಅಥವಾ molecular compounds. ಅದರಲ್ಲಿ ಟೈಪ್ಸ್ ಇದೆ. ಯಾವ್ಯಾವು? ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ಮತ್ತು ಕೋಆರ್ಡಿನೇಷನ್ ಕಂಪೌಂಡ್ಸ್. ಎರಡರಲ್ಲಿ ಡಿಫ್ರೆನ್ಸ್ ಏನು ಹೇಳಿ? ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ನು ಸಾಲಿಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಸ್ಟೇಬಲ್ ಇರುತ್ತೆ. ಕೋಆರ್ಡಿನೇಷನ್ ಕಾಂಪ್ಲೆಕ್ಸಸ್ ಆರ್ ಆಲ್ಸೋ ಸ್ಟೇಬಲ್ ಇನ್ ಸಾಲಿಡ್ ಸ್ಟೇಟ್ಸ್. ಬಟ್ ಡಬಲ್ ಸಾಲ್ಟ್ಸ್ ದೇ ಡಿಸೋಸಿಯೇಟ್ ಇಂಟು ರೆಸ್ಪೆಕ್ಟಿವ್ ಅಯಾನ್ಸ್. ಆ ಅಯಾನ್ಸ್ಗೆ ಬೇರೆ ಬೇರೆ ಟೆಸ್ಟ್ನು ನಾವು ಮಾಡ್ಬೋದು. More salt is an example for double salt. Carnallite is there. Potash alum is there. Unlike coordination compounds, only they are stable in solid state, but even in solutions also they will retain their identity. Identity change agala. So here also you can see examples I had given here. PTF6. This is what? This is complex ion. ಹೌದಾ? coordination sphere ಅಂತೀವಿ ಇದಕ್ಕೆ. ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಬರ್ದಾಗ coordination sphere ಆಗುತ್ತೆ. This is a complex ion. PT is a central metal atom. ಹೌದಾ? This is central metal atom. And F6, what is this F? X minus, halo. This is fluoro. ಹೌದಾ? ಸೊ ಫ್ಲೋರೋ ಇಸ್ ವಾಟ್? ಇಟ್ ಈಸ್ ಅ ಮೋನೋಡೆಂಟೇಟ್ ಲಿಗ್ಯಾಂಡ್. ಆನೈನಿಕ್ ಲಿಗ್ಯಾಂಡ್ ಅಲ್ಲಿ ಬರುತ್ತೆ. ಮೋನೋಡೆಂಟೇಟ್ ಲಿಗ್ಯಾಂಡ್ಸ್ ಎಷ್ಟು ಅಟ್ಯಾಚ್ಡ್ ಇದೆ ಸೆಂಟ್ರಲ್ ಮೆಟಲ್ ಆಟಮ್ಗೆ? 6. Therefore coordination number is what? Coordination number is 6. Similarly here, how many NH3 molecules? 6 NH3 molecules are attached to the central metal atom. Here also the coordination number is 6. Yes, so central metal atom forms coordinate bond, which is also called dative bond. So illi we had seen central metal atom andre enu, central metal ion andre enu, complex ion anta andre enu, ligands nodidivi. We have seen various types of ligands. Two types, monodentate ಮತ್ತು polydentate. Monodentate ಅಂತಂದ್ರೆ single donor site, only one donor site ಇರುತ್ತೆ. There we have seen examples for anionic ligands, neutral ligands and cationic ligands. Polydentate ಅಲ್ಲಿ you have bidentate, which is having two donor sites. En is an example for bidentate ligand. Oxalato is an example for polydentate. DMG and GLY, glycinate and dimethyl glyoximate. Then tridentate ligand, we have diene, diethylene triamine. Tetradentate, triene, triethylene tetramine. Hexadentate ligand, EDTA, ethylene diamine tetraacetic acid. It is having 6 donor sites. ಚಿಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್, ಯಾವಾಗ ಪಾಲಿಡೆಂಟೆಡ್ ಲಿಗ್ಯಾಂಡ್ ಡೋನರ್ ಆಟಮ್ಗೆ ಎರಡೂ ಕಡೆಯಿಂದ ಕೂಡ್ಕೊಂಡ್ ಬಿಡತ್ತೆ, 3 ಕಡೆ ಅಂತ ಕೂಡ್ಕೊಂಡ್ ಬಿಡತ್ತಲ್ಲ, ಅವಾಗ ಇಟ್ ವಿಲ್ ಫಾರ್ಮ್ ಅ ರಿಂಗ್ ಸ್ಟ್ರಕ್ಚರ್. ಅದಕ್ಕೆ ನಾವೇನಂತೀವಿ? ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಚಿಲೇಟ್, ಅಂಡ್ ದಟ್ ಲಿಗ್ಯಾಂಡ್ ಇಸ್ ಕಾಲ್ಡ್ ಚಿಲೇಟಿಂಗ್ ಲಿಗ್ಯಾಂಡ್. ಆಂಬಿಡೆಂಟೆಡ್, it is having two donor atoms, but depending upon the condition and the complex what it is going to form, it will utilize only one gets utilized. ಅದಕ್ಕೆ ನಾನು I have shown the examples here. If in NO2 is an example for ambidentate ligand. Nitrogen use ಆಯ್ತಪ್ಪ, nitro. O use ಆಯ್ತು, nitrito. Cyno, CN use CN. N use ಆಯ್ತು, so it is cyno. NC, isocyano. N is being bonded. SCN, S is being used, thiocyanide. NCS, N is being used, isothiocyanide. Examples for ambidentate ligands. Then pi acid ligands we have. Then we have coordination sphere. Box bracket alli nav ಏನು ಬರಿತೀವಿ, that becomes a coordination sphere. So box bracket alli ಏನು ಇರುತ್ತೆ? It will be having a central metal atom and ligands. Yes or no? Ligands with central metal atoms is kept in the square bracket, and that is called the coordination sphere. Here we have coordination number of monodentate ligands which are bonded. We have one more thing here, that is ionization sphere. ionization sphere. So ionization sphere anta andre enu? The part present outside the square bracket. Outside the square bracket. Outside the square bracket is called ionization sphere. The part present outside the square bracket. Illondistu examples ತೋರಿಸಿದ್ದೆ ನಾನು. You can see here. Yes, here you can see. See K2, I'll write here once again. K2 bracket PT F6 bracket close. This particular part is called ionization sphere. How the sorry, complex this is called a complex sphere, coordination sphere ಅನ್ಬೋದು. ಹೌದಾ? The part which is present outside the coordination sphere, this part is called ionization sphere. It is called ionization sphere. One more example is there. ಏನೈತಿ ಹೇಳಿ? I'm sorry. It is Cu NH3 6 times SO4. This is an example given. So, illi, if you see, this particular part is called what? Coordination sphere. This is coordination sphere, where you have a complex ion in a square bracket. This is central metal atom. This is ligands. Coordination number 6. Outside the square bracket, you have ionization sphere. Ionize agattala. Ionization sphere. Correct? So, one more example in the first itself we had seen CO NH36Cl. So this is coordination sphere and this is what? This is ionization sphere. So this is the brief explanation regarding coordination compounds. So complex compounds, special class of compounds in which metal atoms are bound to number of ions or neutral molecules. These compounds are called coordination compounds. Or complex compounds, they are type of addition compounds. So double salts is there and coordination compounds we have. See, more salt is an example for a double salt also. FeSO4, NH4 twice, SF4, 6H2O. So these exist only in solid state, dissociate into constituent ions in their solution. They retain their identity in solid as well as solution. They lose their identity in dissolved state. They do not lose their identity in loose dissolved state. Their properties are essentially same as their constituent species. Their properties are different from their constituent species. For example, K4FeCN6 is an example for coordination compound. ಇಲ್ಲಿ ಹೇಳಿ coordination sphere ಬಂದ್ಬಿಟ್ಟು ಏನು ಹೇಳಿ ನೋಡೋಣ. Coordination sphere is this part. Yes. So here coordination sphere is this particular part. This is ionization sphere. Howda? Fe is central metal atom, Cn is ligand, cyno. So it is example for monodentate. So coordination number is 6. Yes or no? So like this we need to understand first. Then we can follow the things later. Howda? Then does not show the test for Fe plus 2 and Cn minus ions. This is completely one. This is different. Okay. In double salts, metal atoms, ions exhibit normal valency. In coordination compounds, number of negative ions or molecules surrounding the central atom is beyond its normal valency. That will be a understanding by different theories. We have Werner's theory to understand. Crystal field theory there. Okay, fine. Then double salts, we have seen. See here, aqueous solution of potash alum gives 2K plus, Al3 plus. ಮೂರು ions ಗೂ tests ಇದೆ. Retain. So we can identify them, respond to the different tests. ಅದೇ ನೀವು potassium ferrocyanide ತಗೊಳ್ಳಿ, it will dissociate as K plus and FeCN6 minus. So it will not give test for Fe and CN6. ಅದು ionic test ಬರಲ್ಲ. So that is coordination compound. So central metal ion forms a dative or coordinate bond in the species surrounding it. Complex ions are also known as coordinate ions and hence the compounds. Yes. So Werner's theory we will be taking up in the next session. For now, hope I have made clear all the concepts which have to be understood. Yes, all the concepts are clear. Illi nodಬಹುದು ನೀವು, this is a red thing which is being shown. It is the central metal atom. Ligands are being attached. ಹೇಗೆ attached ಇದೆ? It is through the dative or coordinate bond. Next class, we'll be taking up with the next interesting concepts of coordination compounds. For now, I think I have made the concepts clear. Thank you. Take care.